Hi, this is Group 3 from course SCR 515, and we are here to present our autonomous moving rover project and our rover named Anton. And we have Mas, Jiayu, Zhuoran, and me as Shengdong. And this is the link to our video demo to our software. And to introduce our project, and there are three like examples as screenshots. This is our robot showing in the RVIZ, and this is like the map and the rover showing the gaze ball, and this is our GUI, which can help the user to interact with our software. And then in the presentation, we're gonna have our overview of the project, which gonna say what we have done so far and what the user stories we have finished. And then we're gonna have our collaboration, like how we collaborated with each other. And then we're gonna have our future plan of our project. And Jordan is gonna talk about the overview of the project.
Okay, yes. At the first beginning of this semester, we have a brainstorm meeting, and we design the robots in this meeting. So in the spring one, our main goal is like using some simulation tools to simulate the robots, and try to move robots manually. Uh, but things is not going well in the spring one. So at the spring two, first we finished all the user story in the spring one, and we build a map for the rover to browse, and we also create scripts for running our software. Okay, so when we go through to the spring three, we create a Docker for the development software team, and we also create the GUI for the user. We also create a controller to move robots automatically, and we also build a correlation of voice system. Yeah, that is our overview of the project.
Okay, so for our collaborations, we do have our GitHub page and Taiga page, and what we did bad there is that at the beginning of each sprint, I mean the beginning of the project, we didn't split up our tasks evenly, and we worked together all the way. So which means on the GitHub for now it's only one commit, only one person like commits, which is really bad. And also for a Taiga board, the burden chat at the first time it goes really bad because we haven't like put tasks on there and close it like frequently, and I believe we're gonna do that much better because of our retrospective meetings, and also we conduct our collaborations with our sprint planning meetings at the beginning of each sprint, and also we conduct our stand-up meetings frequently, like 3 times a week, and also we have our sprint review meetings at the end of each sprint to see what we have done so far for each sprint. And then Mas gonna talk about our retrospective of the project so far.
Yeah, about the retrospective, like Shengdong just mentioned before, we started off badly with our sprint one. We didn't even when we finished tasks, we didn't close things on time. We struggled with dividing tasks, and you can see how up and down the first chart is. But we learned from the first sprint, and we applied most of it in our sprint two. Now, talking about the sprint one a little bit more. In sprint one, we had certain goals that we couldn't finish in the sprint one. Specifically speaking about manual rover robot movement. So we carried it over to Sprint 2, and we were able to complete it along with the other goals of Sprint 2 well within time. That it shows you we learned from our Sprint 1, and we were able to implement all our tasks in Sprint 2 very efficiently than before. Also, I would like to add about we ended up finishing it a little bit ahead of time. One of the reasons for this is that we didn't have very large goals for this one because we just wanted to build a proper base for the following sprints. Going on to our last slide, which is future plan. So at the moment, we are working on implementing GUIs for manual control. Like we mentioned before, we have two types of movements, which is automatic and manual movement. Manual movement will allow us to allow the user to control the rover in case it gets stuck somewhere, or in case the user wants to override the automatic control. We would also like to provide our rovers with different options of setup options. Like at the moment, we have our program runs for two-wheel drive differential system. We could implement other types of rovers like four-wheel rovers, or a bigger rover or smaller rover. We want to implement those kind of options so that the user can have different settings of and options for them to choose from. We would also like to use the option to load any map, because in real world you just have to keep the rover, but in our simulated environment we would like to load in any sort of map that we could just plug in and run the rover from and let it discover. Following on, Jai will speak more about.
Yeah. So for our next plan, we are going to implement two sensors in our robot. First, there will be a camera. So basically, the camera is used to capture the pictures of the stuff and obstacles in our map. And secondly, there will be a ladder. The ladder is mainly used to calculate and get a distance from the robot and other things like obstacles. There are two basic sensors in our robots. Another thing we are going to do is to let our robot not only move manually, but also can move automatically, which means it can detect the obstacles in the map and also could use some advanced algorithm to avoid collision. Since we could use the data from our sensors, we can do that. The last thing is that which is our final goal, is to map the whole world. We need to render our map based on the functions above we mentioned. So basically, we need to use the camera and radar data to render our map. And yeah, that will be our future plan. That's it.
Okay, thank you for spending time with us.